Good morning and welcome back to school. It's good that we're all online now. I think it's going to be better for us to be all on the same page instead of being at home and not being able to get in contact with me or other students that are asking me questions. So I'm actually glad that we're all on the same page now. I'm going to be hosting class every day we have class, and I expect you all to show up. Attendance is mandatory. And I think it's going to be very helpful for you to show up and ask any questions. I'm going to be making those videos, so I'm going to be keeping classes short and mostly focused on questions or just reviewing what's expected of you. Okay? Today we're starting our unit on percents. It's going to be a short unit, probably going to take 2 weeks. And there's going to be a small project involved next week. Okay? Today I just want to introduce percents to you. So we're going to review common denominators. This is related to obviously fractions. We're going to look at how we can convert fractions to decimals and percents. We've done this part of it in our fractions unit, but we're going to add the percents now. And you'll see how simple it is. And then we're going to just make sure that we can compare fractions, decimals, and percents to see if we have 3 values in 3 different forms, like a fraction, a decimal, and a percent, we can tell which one is the greatest and which one is the smallest. Okay, so let's get started. And let's start with review. So let's look at common denominators first. If I want to add 3 over 4 plus 5 over 6, I can't just add them right away. If you remember, from our fractions unit, we have to find common denominators first. You have a 4 and a 6, so we need to find a common multiple. The easiest way to do it is just multiply this side by 6 over here, and this side by 4. And then we get common denominator. We get 24 here and 24 here. But we can also do something which probably some of you already noticed, is that we can just find a different common multiple. So if we multiply 4 by 3, we get 12. If we multiply 6 by 2, we get 12 as well. I'm going to do this because it's easier and it's kind of a shorter way to the final answer. So 3 times 3 is 9, 4 times 3 is 12, 5 times 2 is 10, 6 times 2 is 12. And so now that we have a common denominator, we can add, and 9 plus 10 is 19. And so our final answer is 19 over 12. We can't simplify this because 19 is a prime number. And so this is our final answer. Now, the question here is, what if all fractions had the same denominator? What if instead of having to get a common denominator every time, what if all fractions had the same denominator? That would make life so much easier, right? You can just add right away without thinking about getting a common denominator. And that's the whole idea of percents. When we talk about percent, the word actually just means out of 100. Okay? So it's basically saying that whenever we say, let's say 5%, it's just a fraction with a denominator of 100. So it's 5 out of 100. If you score 5% on a test, then you got 5 out of 100. If you score 90%, then you got 90 out of 100. And so the common denominator here, or the denominator here, is always 100. And so percents is a way to make communication easier. If we all agree that we have the same denominator, then life becomes a little bit easier. Okay, so this is all we're doing. And so you can think of percents as just an extension of fractions, where the denominator is always 100. All right. So let's look at how we can convert some fractions into percents. If I have a fraction of 3 over 5, the one step we have to do basically is just make the denominator 100. So we have to ask ourselves, what do we multiply 5 by to get 100? If you don't know, you can easily just do some long division. So 100 divided by 5 doesn't fit into 1, 10, so it becomes 10, subtract, and then we have an extra 0 here, so we put it up here, right? So times 20 times 20. And so 3 over 5 is 60 over 100, which, since it's 60 out of 100, we can just say 60 This is what that sign means, is out of 100. Okay? 7 over 50. This one's easy. 50 times 2 is 100. So we have 14%. And then this one's kind of tricky. 30 over 40. 40, we can't multiply 40 by anything to get 100. 40 times 2 is 80. 40 times 3 is 120. But we can simplify this fraction. If we divide both of them by 10, we get 3 over 4. Now, 4 we can multiply by something to get 100. And so if we divide 100 by 4, 5. So we can multiply both the numerator and denominator by 25. And we get 75 over 100, which is 75%. So far, so good. So the whole goal here is to convert the denominator to 100. Now, this one's kind of tricky because we can't simplify this fraction. It's still 40. The denominator is still 40, but we can't simplify this fraction. And so, let me clean this up a bit. And so we're going to do the same thing. We're going to find out what do we multiply. Maybe this in blue. What do we multiply by 100 to get, what do we multiply by 40 to get 100? And so I'm going to divide 100 by 40 again. In this case, since we're dividing, we can actually cancel out these zeros. So it's exactly the same as saying 10 divided by 4. Now 4 fits into 10 once. Twice. We get 8. We have a remainder of 2 once we subtract. And we're out of digits here. 10 minus 8 is 2. So when we're out of digits, we add a decimal point. And we can add another 0. So we drop down this 0. 4 fits into 25 times. And so we can see that our answer is 2.5. So 40 times 2.5, numerator and denominator, is going to be 100. Let me keep it in blue. And then what's 17 times 2.5? Well, we can do this on the side here. 425. But remember, we have a decimal place here, so we have to add it back one decimal place. So our final answer is 42.5 out of 100, which means it's 42.5%. Now, when we did our fractions unit, we discussed how we can't have a decimal in a fraction. That wouldn't be in simplest form. But since we're forcing the denominator to be 100, then it's okay to have a decimal as a percentage. Okay, so that shouldn't bother you. 42.5% is valid and in simplest form. Okay, now let's look at decimals. We want to convert decimals into percents. Okay, and what you have to remember about decimals is that the denominator is always 1. If I say 0.5, it's as if I'm saying 0.5 over 1. There's always the invisible denominator here that we don't need to write, right? And so all we have to do is just multiply by 100. It's as if we're multiplying both the numerator and denominator by 100 to get the answer, right? But we don't have to write this because it's just 1. So 0.5 as a decimal. Oh, power went out. That's all right. 0.5 as a decimal. So 0.5 as a percentage, I mean, is going to be 0.5 times 100. So we have 0.5. If we multiply by 100, we move the decimal point twice. So 1, 2. It's going to be here. This is an empty space. So we have 50. So 50%. That's easy. 1 times 100, again, is just going to be 100%. So 1 is just 100%. 0.78, same process. 1, 2, it's going to end up here. So it's 78 over 100, or 78 out of 100, which is 78%. And this one, last one, again, times 100, so it's 7%. Notice how the 7 here was in the hundredths place, and so when we multiply by 100, it just becomes 7, whereas here it was in the tenths place, or 10th place. That's why it became 78. All right, so far, so good. If you don't remember how to convert fractions to decimals. Remember, it's just long division. So if I, so look at this. Let me take the example of 3 over 4 here, or yeah, 3 over 4. So if I have 3 over 4, that literally just means 3 divided by 4. How many times does 4 fit into 3? 0. So we're out of digits, so we add a decimal. We can now add a 0 here. 4 fits into 30. How many times? Let's see, 7. So 4 times 7 is 28. So we subtract, 30 minus 28 is 2. We can add another 0 here since we're after the decimal point. And we can put it down here. 4 fits into 25 times. And so you can notice here that our answer is 0.75. So if 3 over 4 equals 0.75 as a decimal, both of them have the same, or convert to the same percentage, which is over here. It's 75%. You see that? All right. And then in the last phase, we're going to look at comparing them. And the whole idea of comparing them is making sure that they're all in the same form. It's harder to compare things that aren't in the same form. So if we have, how can we put them in order of smallest to largest? And what I'm going to do here is I'm going to convert them all to percents, just because in this case, for me, I think it's easiest. So this is already percent. We don't need to change it. 76. 0.82, that's the converting decimal is easy. I just multiply by 100. So it becomes, move the decimal twice, it becomes 82%. So we already know that this is greater than 76%. And 3 over 5, I can just multiply the 5 by 20, or the numerator and the denominator by 20. So it becomes 60 over 100, which is 60%. So we can tell that this is the smallest. So if we want to put them in order, it's going to be 3 over 5, then 76%, and then the largest one is 0.82. Okay? This is basically it for today. You have a math-based assignment, and next class we're going to talk a bit more about percents. It's gonna get a little bit more complicated, and then we'll start right away on our project. All right? Good luck. I am excited to see you on Zoom. If you watch this before the Zoom, give me the code word. The code word is hot sauce. If you give me this code word, you're gonna get 10 stars. Okay? So make sure to let me know if you watched this before the Zoom. If you watched it after the Zoom, then you won't get 10 stars, even if you know the code word. All right? Good luck, and I'll see you in class. Bye.